morning, everybody. I don't know why I'm here, because my background is solar system exploration, science mission, and I will not give a talk on science mission, but we'll give an overview of why there is a return to the moon, and why this return to the moon is to prepare for Mars. Sorry, it's not so good. Yes, this one. So I will not discuss all those wonderful missions in preparation, JUICE that has been launched recently, what we are preparing for with Envision, what we have done for Rosetta, and so on and so on. So I will not discuss those items. I will come back in 1952, a famous engineer, Wernher von Braun, which was in the United States and, well, not very busy, probably. He wrote a book, The Mars Project. So 70 years ago, the idea was to go to Mars, and Wernher von Braun was very ambitious. You see the ideas is to have 10 spaceships, 70 crews, and 4,000 tons of to go to Mars. So very ambitious. There is a big rocket, like the Starship, 77 motors, and we are 5 years before Sputnik, so before the beginning of space activity. And Wernher von Braun was so ambitious that the way he wants to go to Mars was to land horizontally. We know today that it was not a good idea, but anyway, it was the Mars project, and since that time, the idea is always in the spirit of a lot of people. Just back to Apollo mission by some numbers, it was roughly a 10 years project with the famous keynote in 61, John F. Kennedy, and the end in 72. $24 billion in 69, this means 155 today, 2% of the US budget. 400,000 people, 100 universities, 382 kilograms. And at the end, it's not a scientific mission, but at the end, more than 12,000 publications, mainly on the analysis of the lunar sample. And for human spaceflight, the idea is, if you see how the NASA budget evolved during the Apollo mission, in 61, another was roughly nothing, 500 million per year. And in 65, at the top of the activity on Apollo, the budget raised to 4.5 of the federal budget, US federal budget, which is quite a huge budget. This means, to compare to today, this means the NASA budget should raise to $185 billion, compared to the 23 billions of 2023. So it will not happen, of course. And so the way you want to go to Mars will be different than the Apollo, well, all have been done in parallel, Saturn V, LEM, and so on. And the exploration of the moon, so there were the big activities to prepare the Apollo mission, the Apollo itself, and then nothing in the 80s and roughly 90s with a small Clementine, lunar prospectors. And then there is a race in the 21st century, and today there is more than 30 missions in preparation, which are from institutional but also commercial mission. And after Apollo, something went obvious. The obviousness was you need to be to use reusable launcher, because you launch Saturn V and you return just a small capsule, so you lose all the item. And so the idea was to do the space shuttle. And the space shuttle is a 40 years activity. It will sell to be reliable and cheap, and to have very frequent fly. At the end, it was flight 135, and the frequency was very low, 4.4 to 5 launch per year, 20 times less than the expectation, 20 times less. It was very complex, dangerous, 2 times there was a failure, and quite expensive, around 1.5 billion per year. At the end, the budget of this program was $170 billion. And in parallel, you have to go somewhere, And in the early 80s, the idea was to build a huge international space station. It's a half-a-century program, which is not over. It will probably end around 2030. You have the NASA, Canada, ESA is part of this program, Japan and Russia. It's 450 tons. It's a six crew full-time. And roughly, the overall budget is 150 billion on half a century again. So 3 to 4 billion per year. And back to the moon. Back to the moon, you have, as I said, roughly 30 missions in preparation. 30 missions, 30. And 10 countries, including ESA, but not France. And you have two types of missions, the classical institutional mission on the left, and what we call commercial mission on the right, with, for example, the Commercial Lunar Payload Service program at NASA. And this is some example of those missions, like Chang'e 4 that land on the moon, Chandrayaan 2 that failed to land, etc., etc. And just as an example, very recently, the Akuto R lander landed but failed to land. It crashed on the moon. And on board there is a Emirates rover with some French camera. But again, space is hard, and landing on the moon is not easy. After the failure of Israeli lander, the Indian lander, and now the Japanese lander. So we expect to be on the M3 lander with a seismometer, which is derived from InSight mission, which was a very good success, and we know what is inside Mars planet. And so we expect to launch this on May 25. There is also a Chinese program, very ambitious program, with Chang'e 1, 2, 3, 4, 5, and probably 6, 7, and 8 for the future. We already have the first Mars sample return since 72, and it's a showcase. It's technology-driven and very ambitious and reliable. All the mission was, Chinese mission has been a success. For the US, there is an important report, and a lot of things, I will say, come from this pathway to exploration. You can find it on the internet. It was published by the National Research Council in 2014. And in this report, it is written that the horizon goal is Mars for human space flight. And amongst the different possibilities, the moon, asteroid, Mars, and the moon of Mars, Mars is the most difficult ambitious program. And it will require a lot of resources, and it will have unprecedented technical risk, fiscal risk, programmatic challenge. And thus, the horizon goal is Mars, and all the activity on the US side is to prepare for those Mars missions. One key trade-off, and for long times, nobody knows what will happen. You have two ways to go to Mars and to stay to Mars. There is a long stay, which is a natural mission with 6 months first flight to go to Mars, more than 1 year to stay, and then 6 months to come back. And this mission is optimized in terms of delta velocity and in terms of the size of your tank of the rocket. But you can have also a short stay. This means 6 months to go, you stay only 1 month, and then you have more than 1 year to return, and it's more expensive. You have to make a flyby from Venus, and during a lot of decades, we don't know what NASA will decide. And we know today that the decision is to be on a short stay, and this will have some consequence. There is some difficulty. As I said, for example, the rocket should be more efficient. If you compare on this slide the delta velocity, which means the size of your rocket, the size of the tank of your rocket with the fuel inside, and the mission duration, so you have the Mars surface for the long stay on the right with And you see that the delta V is around 25 kilometers per second, which is quite a lot, compared to 7 to go to low Earth orbit. For a short stay is more. It's around close to 30 kilometers per second. And the mission is 600 days. And you can imagine also to have Mars flyby. So probably Mars flyby will happen, but it's, the objective is this mission, and which is quite difficult and ambitious. One consequence, for example, is you cannot go straight on and say, okay, we go to Mars and we go directly. This is impossible. You need pathway. This means you need to go from low Earth orbit to Mars surface. And pathways are not geographical step, but strategic step. This means you need, during this step are necessary to develop the system, to develop the rocket, to develop the vehicles you need to go to Mars. And so at the end, the decision has been taken. The first conclusion is what is promoted by the Mars Society, Robert Zebrin. It's a direct mission to Mars. This is impossible. That's the first consequence. And the second one is that in 2015-17, NASA decided to choose the first step. And the first step was the Lunar Gateway. And in 2017, this is a Lunar Gateway with all the classical partners, ESA, Canadian, Japan, and Russia. And it was an ambitious station around the moon with 11 modules. But, as you know, Trump decided also to go to the Mars surface, and there is another event in Russia decided to withdraw, so Russia is no more a partner. And due to the Trump decision to go to the Mars surface, to the moon surface, NASA has to shrink this gateway. And so this is the recent version of the gateway with only an habitat module and a PPE, power and propulsion element. And you see that there is, Europe is here with the logo here, ESA. This is a European service module. Each time astronauts go to the moon or go to the moon orbit, there will be the ESA European service module. So this means we will have European astronauts on board the gateway. And in 2021, NASA has to send an AO to select the human landing system. And the human landing system was to 2024. We know today is probably 2025 and probably later. So three different competitors, Blue Origin, Jeff Bezos, proposed this concept, which is quite classical, a two-step lander. The idea is to have 2 crew on the moon and 2 in orbit. A second competitor, Dynetics, 2,000 employees, also a classical concept. Remember, we go to the pole, so this is why the solar panels are vertical and quite huge. And the third competitors, as you know, is SpaceX, 12,000 employees today, and propose a Starship. Starship is the second stage of the Starship, which is this vehicle on the moon. And in spring 2021, Starship is selected, which was a huge surprise. And one reason is that SpaceX is cheap, and also because SpaceX was in advance in terms of technology readiness level compared to the other, which has done only paperwork on their concept. But dispute, because Jeff Bezos was very upset of this decision. Just a word about Starship in Boca Chica. So this is the way it is. 23 motors, and Starship is the biggest rocket in the world, as you know. It also is a real disruption. The disruption is the cost to go to space. You see the Starship cost is around $100 per kilogram, which is a big decrease in terms of cost. And Of course, it's theoretical, but it will be that price if all the Starship is fully reusable, which is a huge challenge. And as I said, Bezos was very upset. He published propaganda. This slide was on a tweet, but this slide is completely wrong. So the idea is for Artemis 3, which is to go on the surface of the moon, you need, if you trust Bezos, 16 launch of the Starship just to fill a tank, and at the end you launch your HLS, and you put all the ergol on the vehicle that will go on the moon orbit, and then the Orion will be launched with SLS, dock on the HLS, and land on the moon, which is a very, very ambitious endeavor. Alors, it's a propaganda, but this is not completely wrong. Just remind you that the Starship is fully reusable, and the way Elon Musk wants to bring back the Starship to have all those launch possible, 2 launch per month. So this is the way it will work. The heavy booster will land and will be catch before touching the ground. I will do that again for you. So the heavy booster will land here, will be catched by those items, and then will be put on the pad, fill again, to be launched on the second time. So this is very ambitious, and as you see on the first launch of the Starship, April 20th, so you remember, everybody has seen that. First, there is some motors which not on, 6 on the 23rd and 23 motors was off. And of course, there is some rapid, unscheduled disassembly, as say Elon Musk, which is what's happened. More seriously, there is some problem on the pad, and if you want to have a reusable system, so you see that it's not reusable. So there is some issue to solve before the system will be fully reusable, and the tank also makes some damage. So I think SpaceX has a lot of work before the system will work. And during that time, at the end of 2022, the Artemis 1, without any astronaut on board fly, it was a perfect mission, and the mission is close to Apollo 13. This means you go around the moon and then you come back, which is an automatic mission. It was a qualification of the SLS and the Orion capsule also, and the European Service Module. Come back to the Artemis 3. So this is a NASA slide. You see there is all those launch to fill the propellant and then go to orbit, and you have the Orion then, and you come back with Orion. This is the way it will done with Apollo Artemis 3. The first slide of this Starship was this one, and then SpaceX works a little bit, and now it is this one. So one difficulty is you will have to land on the moon. The moon is not flat. Remember Apollo 15? It was a 12 degree. So if the Starship land like Apollo 15, something will be not very good. So there is difficulty here. And this is the NASA manifest, and you see on the NASA manifest different things. ESA is there. There will be ESA astronaut. And you see the SpaceX is only for the Artemis 3. And then this is to be defined. So we know there is another competition to select another human landing system, and we will see what will be this system, probably Bezos, but this has to be confirmed. And again, to go to the moon is to prepare Mars. And of course, you will prepare, the gateway will be a preparation of the system that will go to Mars. This is a nuclear vehicle here. You have nuclear fission on the moon. Probably you will need on Mars if you want to make ISRO and ISPP, Insidious Propulsion. You will have pressurized rover and also on Mars, etc., etc. So all what will be developed on the Moon can be transferred and adapted to Mars. There is a lot of commonality. On the Moon, there is a big idea, is to go to the South Pole, North Pole or South Pole, because South Pole probably there is more water ice than North Pole, and this is the South Pole, and all what is blue, there is some water. Inside cold crater, but probably outside also. There is a key question. The idea is that if you can take the water from the South Pole, the cost of this water is very low, $500 per kilogram on this estimation. And if you bring the water from the Earth, it's $35,000 per kilogram. So there is a huge interest to exploit the water from the Moon. The question is, we don't know if it will be feasible. We've never been to the South Pole. And we will go to the South Pole. NASA will go with Viper, which is a quite big CLPS lander, and the launch has been delayed to the end of 24. And with this lander, we will know how much there is water on the crater, inside, but also outside. And if you can exploit the water outside, it will be more easy. Inside the crater, which is dark, the temperature is minus 200 degrees C. So it's a big challenge to go inside those craters. So we have to wait if there is a lot of water and if this water is exploitable. Now I'm coming to Mars. And why is it so difficult? Mars is, let's say, 100 times longer mission and 1,000 times faster. You have 400 kilometers to go to the Moon. You have probably 400 million kilometers to go to Mars. So everything is bigger when you go to Mars. And you have here the item. You will need probably, not all, but probably you will need to develop this to go to Mars. For example, the spacecraft that we have to wait in orbit, and this spacecraft has sent the astronauts around the Mars orbit. You have to wait probably 7 months, perhaps more than 1 year. This spacecraft is quite heavy, 300 tons, 400 tons, we don't know exactly. And the problem is to have cryogenic propellant are not suitable because you cannot store those propellant during many months. So you have to make new development in terms of propellant. This means new motors, probably less efficient motor, with an idea, again, one idea is to use nuclear propulsion, because we know that nuclear propulsion is more efficient. If you will use electric propulsion, it's 10 to 20 times more efficient. It's in the size of your tank of your rocket are 20 times less important than chemical propulsion. But for the electrical propulsion is low thrust, so it's only for cargo. If you want to send men, you will need nuclear thermal propulsion, which is 3 times more efficient. And we can imagine to go to Mars with this type of vehicle, which is an R&D activity in NASA called DRACO, and we expect a demonstration in 2027 if we follow the NASA schedule. We need, if you want to exploit the water on the Moon or on Mars, you will need energy. On Mars, you cannot have sun energy, so you will need also nuclear energy. So there is also an R&D activity named Kilopower, which is a very small nuclear reactor, 1 kilowatt, with the idea to be scalable to tens of kilowatt. And roughly to exploit the water on Mars, you will need 100 kilowatts of energy. So there is a risk, political risk, to launch this nuclear, and the problem is to be plug and play for this type of nuclear reactor. So that's a very important challenge. And probably the most difficult to go to Mars is to land on Mars and also to take off on Mars. So there is different ideas. Again, SpaceX wants to use the Starship, and you will use what we call L over D bigger than 1, and then a vertical landing. This is the Starship concept, and the NASA concept is more on the inflatable shield, but in any case, this is the size of the lander. It's 40 ton, 80 ton, depends on how much ergol you put on it if you want to take off. And on the report, it is said that this is the more difficult item to develop. And in 2014, it says that nothing will happen before 2040s. And so this is the idea of the agenda and the calendar. The Mars Ascent Vehicle is also very difficult, probably the most difficult one. This is a concept, it's just a beautiful drawing, but it's roughly a system that have to land and that have to take off. And the big challenge is to know if your rocket here is full of ergol when it lands or not. This means, do you have to make the ergol on Mars, what you in situ propellant production, or do you have to send the ergol to Mars? If you want to send the ergol to Mars, this is the cost of the transportation. To have 1 kilo of ergol on Mars, you have to send more than 200 kilograms to put your 1 kilo on the surface of Mars. So the cost of the transportation is quite huge. This means if you compare what you can do if you put a system to make ISPP, you have to land 3 tons. And if you have to bring back all the ergol, you have to land 30 tons of ergol for the MAV. And the question we don't know if it will be feasible. We don't know how much water there is inside the ground, and we need a demonstration. There is a demonstration of Mars 2020 with MOXIE for the CO2 to make oxygen, but we need the demonstration with the H2O. And for example, for a long stay on Mars, you need 68 tons of water to support all what you need on a long stay. 68 tons that have to be produced on the surface of Mars, of course. Some word about the radiation. This is what we call in France roulette russe. For example, this is the Apollo mission, 11, 12, 16, 17. Between 16 and 17, there was a huge solar eruption. This one is instant depth in French, more instantaneous. So this means if Apollo 16 was during this eruption, the astronaut would be dead. So this is the roulette russe. There is a way to be protected. You need a shield, but if astronauts are on the surface in extravehicular activity, there is really a danger. For Mars, it's the same thing. And at the end, the dose on Mars is around 1,000 millisievert, 1 sievert. And NASA changed the rule. The rule becomes 600 millisievert with no sex and age dependency, which is close to the limitation for the Mars mission, 1,000 millisieverts. Compared to ESA, which is 1,000 millisievert, Canadian Space Agency, 1,000 millisievert. You have to read what is here. Could be exceeded with individual waivers. This means probably the astronaut will sign a discharge saying I will accept to receive a big dose. And the astronaut will not die during the mission, but they could have some impact in their health in the 20 years after the mission. In summer 22, last year, NASA published this ideas of the minimal, what I call the minimal concept of a Mars base. It's not a Mars base. It's an outpost. This means it is like Apollo. You go somewhere, you don't go at the same place. And what is it? You have to deploy first a cargo with a lot of ergol inside, no ISPP, no ISRU, You deploy then the crew ascent vehicle, which is empty, and you have the rover to fill with air gold this crew ascent vehicle. If everything is okay, you send the crew, 2 people, during 30 days mission on the pressurized rover. One big item is the spacecraft that will send all these items to the Mars orbit. This is a minimal mission. And I don't know what will happen, but it could be the way you will say, okay, we are on Mars with this type of mission. There is no Mars base, and there is 2 people during 30 days. On the question why there is Mars mission, this is all the answers. No, there is no real unique answer for that. This is political reason, let's say like that. Probably, anyway, so we can discuss this aspect. It will be too long to discuss. I have a last argument, which is that USA spend 50% of the US space budget to human space flight. ESA is only 10%. Why, when you have this type of involvement in human space flight, you have a strong internal lobbying, industry, state, Congress, to maintain those 70,000 employment. So Mars is a perfect objective because it's a very long term and get a vision to US space program. In the US and at ESA also, you need to have a vision, and Mars is a very good mission. So just to conclude, human mission to Mars seems impossible, yet it is in preparation. It will be the iconic program of the 21st century. Thank you.